We have been using the graphing calculator to solve quadratic equations, only focusing on looking at the table. We would enter our equations, look at the graph, then hit second graph, and we were finding where y1 equaled y2 and naming x as the solution. Now that worked great, but it only works when our values are whole numbers. Many times you're going to get decimals. So I'm going to show you another method to find the solution of quadratic equations using what's called the intersect, or looking for the intersection. So let's begin by, in our graphing calculator, entering problem 1. 12x squared will go on y1, and on y2 I'm going to put 5x plus 2. And then I'm going to hit graph, and my graph looks like this. There's a parabola, then a line going through it. So I'm going to sketch that right here. And then I've got this line going through. It's kind of hard to see. So let's go look at the table and see if we can find out where that happens. Second table. I'm looking through, I'm scrolling around. When you start seeing numbers in the hundreds, I'm not going to give you anything that big. So as I'm scrolling around, I do not see anywhere where y1 and y2 are the same value. But when I look at the graph, the one I drew and the one here, they clearly intersect. So I'm going to use another method to find those values. So these are the notes I'm going to use where it says from the graph. So I'm going to be reading from those notes. I'm going to push it up a little higher so you can see the notes as well as my graphing calculator. So in order to use this method, I enter my two equations. We will always check the table first, but when you don't see it, you're going to do this. I'm going to push second and trace, second, then trace, and then I'm going to select 5. That says intersect. And it says first curve. When it says first curve, I'm going to hit enter, and you can see my cursor is right there flashing. Then it says second curve. I'm going to push enter again, and then it says the word guess, and I'm going to press enter a third time. And then you will see the word intersection. So notice the intersection is when x is negative 0.25. That will never show up in the table because it's a decimal. It's a fractional amount. It's not a whole number, but that is one of our solutions. We don't care about y. So we've got x equals negative 0.25. So there is some sort of intersection also happening up here. So I want to take a look at that. I'm going to go through this whole process again, and that's what it says down here. If the two graphs cross in more than one place, you need to repeat steps 2 through 7. So I'm going to start by hitting second, trace, and then hit 5. And then before I go to step 4, which is to hit enter at the first curve, I want to move my cursor up here where there must be some other intersection. And then when it says first curve, I'm going to hit enter, second curve, enter, guess, enter, and it says the word intersection, and it's giving me a new x value, and that is x equals 0.666, lots of 6's, then a 7. I do need to round to the nearest hundredth. That means I want to only have 2 numbers after the decimal. So because that third number is a 6, 5 or above, give it a shove. I'm going to have my solution be x equals 0.67. So I'm going to write comma 0.67. So those are my solutions using the trace method.